Hey everybody. We've been doing a lot of work with rational numbers lately. Tonight we're going to talk about some of the properties of rational numbers. So these are properties that apply to every rational number. The first one is the inverse property of addition. The inverse property of addition says that the sum of a number and its additive inverse or opposite is 0, right? And we've seen that before. We've seen that any number, say 5, plus its opposite, negative 5, equals 0. And that applies for any number. If we take any number a and we add the opposite of that number, we will get 0. The identity property of addition says that the sum of a number and the additive identity 0 is the number that you started with. Negative 7 plus 0 equals negative 7. The identity of the number doesn't change. That's why it's called the identity property. So if we take any number a and we add 0, we will always end up with a. That's why 0 is called the additive identity. There is also an inverse property of multiplication, just like there's an inverse property of addition. The product of a non-zero number and its multiplicative inverse or reciprocal is 1. So the multiplicative inverse of any number is the reciprocal of that number. So here we have 3 over 4 times its reciprocal, 4 over 3. 3 times 4 gives us 12. 4 times 3 gives us 12. And 12 over 12 equals 1. The same thing applies when we don't know the numbers. If we know the variables, as long as these aren't 0, a over b times b over a equals 1. The multiplicative inverse is the reciprocal of that number. The additive inverse is the opposite of the number. Then there's the identity property of multiplication. The product of a number and the multiplicative identity, 1, is the number. So just like the additive identity was 0, the multiplicative identity is 1. Because if we multiply a number by 1, we get that number again. 9 times 1 is 9. Negative 6 times 1 would be negative 6. So if we have any number a times 1, we just get a. That's the identity property of multiplication. So the multiplicative identity is 1. Now that we've written down those properties, let's see if we can identify those properties when we see them in a problem. In example A here, I have a number, negative 4/5 times negative 5/4 equals 1. So since I see multiplication, I know it's going to be one of my multiplication properties. And I see a number multiplied by its reciprocal, its multiplicative inverse. So we know this is going to be the inverse property of multiplication. And whenever we multiply a number by its reciprocal, we get 1. So because it equals 1, that's another clue. Inverse property of multiplication. Now we got to make sure we put multiplication here because remember the inverse properties are different. In example 2 here, or example B I should say, we have negative 3.5 plus 3.5 equals 0. We know this is going to be one of our addition properties, and I see a number plus its opposite equals 0. So remember its opposite, another word for that, is the additive inverse. So this is the inverse property of addition. Right? The multiplicative inverses and the additive inverses are very different. So we've got to make sure we're very specific here when we're writing down the property we're using. Example D here, I left out example C just because I didn't like it. Example D here, we are multiplying, it looks like we got negative 7.9 times 1 equals negative 7.9. It's a multiplication problem. I don't see any inverses, I don't see any reciprocals here, and I see a number times the multiplicative identity. So this is the identity property of multiplication. Identity property of multiplication. Okay, last thing we're going to cover for tonight is we're going to go back to something we've worked on a couple times, which is ordering numbers from least to greatest. We've done this before with just integers, and we've done it with positive and negative decimals and fractions, but those fractions that we did it with before were pretty familiar. We're not always going to get nice clean fractions like 1/2 or 1/4 or 3/10. Sometimes we're going to get something more like we see in example 1 here, where we have 5/8. All of the other numbers are already in integer and decimal form, so those are pretty easy to compare, but this negative 5/8 here is kind of tricky to compare to the other numbers. So we can do what we were working on yesterday, and we can divide 5 by 8 to turn it into a decimal. Now, 8 doesn't go into 5, but 8 does go into 50. 8 goes into 50 6 times, because 6 times 8 is 48. So I write 48 here, I subtract, and I get 2. Now I'm not done, so I can add another 0 here. Now 5.00, that's not changing the number. Bring this 0 down, and 8 goes into 20 twice, because 2 times 8 is 16. I subtract there, I get 4. I need another 0 to bring down. And now I have 40, and this is nice because I know 5 goes into 40 evenly, so I know I can be done here. That's 5. 5 times 40 is 40. I subtract, and I get 0. Now I just have to bring my decimal straight up. So negative 5/8 is the same as negative 0.625. So now when I'm ordering these, I know negative 1 is my lowest integer. Now I have negative 0.625 and negative 0.8. Negative 0.8 is going to be closer to negative 1. And then comes negative 0.625. That's going to be closer to 0 than negative 0.8 is. And then I have my positive number last of all. In example 2, we have 4 and 1/5. Now, you might remember what 1/5 is as a decimal, but if you're not sure, we could always do 1 divided by 5. Now 5 doesn't go into 1, but I can write it as 1.0, and 5 does go into 10. 5 goes into 10 twice. 2 times 5 is 10. We subtract, and we get 0. So we can be done, and we just put our decimal right there. So 4 and 1/5 is the same as 4.2. And then we have negative 3.6. Now, 8/9. Negative 3 and 8/9. I'm going to have to divide 8 by 9 here to get my decimal for my fraction. Now 9 doesn't go into 8, so we can make it 8.0. 9 does go into 80. It goes into 80 8 times, actually, because 8 times 9 is 72. Subtract there, I get 8. 80 minus 72 is 8. I'm going to need another 0. I bring that down, and I get 80 again. 9 goes into 80 8 times. 8 times 9 is 72. Uh-oh. I think I'm stuck in sort of a pattern here that doesn't seem to be changing. I have 80 again. So what does that tell me? That tells me that this 8 here is just going to keep going forever. I bring my decimal, I put it right there, and what that is going to give me is 0.8 repeating. So I can write this third number as negative 3.8, and that's repeating, and then we have 0. So if I'm looking for my lowest number, I got 2 negatives here, but negative 3.888 on forever is less than negative 3.6. So we'll put negative 3.8 repeating, negative 3.6, then 0, and then my positive number. And you know what I should do really is, all these numbers that I changed, I should change back to their original form. So let's change this back to negative 5/8, and we'll change negative 3.8 repeating back to negative 3 and 8/9. Negative 3.6, that's its original form, 0, and then 4.2, remember, was 4 and 1/5. So there is our numbers in order from least to greatest. Alright, that's it for tonight. Don't forget to finish your notes and make sure you submit them, and I will see you guys tomorrow.